All right, for this problem, they want you to draw the graph of the inequality y is greater than 4x plus 3. And if you forgot how to do this, you can go back and refer to the participation activities 11 and 12 in the reading and participation section. Graphing linear inequalities. But anywho, part A says find 2 points on the associated line. You'll notice that up here it has a greater than sign, but here it has equal to signs. The equal to signs is actually the line on the graph, but then when they put an inequality in there, that opens it up to more possible answers. So you end up shading your graph for more points that might work in an inequality. But for part A, they want you to plug and chug the numbers. It says find 2 points. Often it's smart to start with the values of x equals 0 and x equals 1. That's because 0 and 1 are the most user-friendly numbers in the world. When you add 0 to anything, it doesn't change it. When you multiply something times 1, it doesn't change it. So they're easy numbers to work with. So if we stick the 0 in here, we're going to get 4 times 0 plus 3. And according to order of operations, you'd multiply first. So 4 times 0 is 0. 0 plus 3 is 3. So the number that we would put here is 3. That is the ordered pair of 0, 3. Then you do the same thing, but with the number 1. And you're going to stick a 1 where this x is. So that's going to be 4 times 1 plus 3. 4 times 1 is 4. 4 plus 3 is 7. So the number that's going to go here is 7. And again, that's the ordered pair 1, 7. Now, those 2 points are on the line. So whenever you draw your line, somewhere on that line will be that blue point of 0, 1. Somewhere on that line will be the red point of 1, 7. Okay? Now, part B says, find a point that satisfies the strict inequality of y is greater than 4x plus 3. Well, that means that it won't be on the line, it'll be above the line. And they have specifically given you the x coordinate of 0. Now, when we stuck 0 in up here, right, we got 3. Well, anything greater, we end up, technically this is, let me go back to the blue pen. This is y is greater than 4x plus 4 times 0 plus 3. So you would get y is greater than 3. When x is 0, you want any y that is greater than 3. So just pick one. There's actually an infinite number of answers that you can put in this box, but I'm just going to go with the next largest number, which is 4. Any number you pick that is greater than 3 will work in there, because you're now satisfying the inequality of greater than, whereas when I was doing it up here in the blue, I was actually working with equal to. When x is 0, y equals 3. But then when they say when x is 0, y can be greater than 3, that would be 4 or 5 or 6 or 7.2. I mean, there's just a bunch of numbers you could put in there. So when I go back into Mobius, let me find that. Here it is. Here's my number. 0 and what was it? 3. And then 1 and 7, and then I said 4, and then there's a part C, which I just have to do this. It says to sketch the inequality, first sketch the boundary line using this. So I'm going to click on that, and you're going to use these 2 points up here, the 0, 3 and the 1, 7. So I'm going to go x is 0, that's right there, y is 3, 1, 2, 3, click on the point. And then when x is 1, y is 7, 5, 6, 7, and there's the line. Now, you have to shade it. It says first sketch the boundary line using the icon and then use the area icon to choose either the region above the line, which would be this region here, or below the line, which would be this region there. The quickest way to figure out where you're going to shade is to use a test point. And the origin right here to me is always the best number to test. So I'm going to go back to this, and the original equation was right here. I'm going to use purple for this. If I stick 0 where y is and 0 where x is, I want to see if the greater than holds true. Well, on the left, 0 is just a 0. On the right, 4 times 0 is 0, and 0 plus 3 is 3. So the question is 0 greater than 3? No. 0 is not greater than 3, which means the point 0, 0 should not be shaded. So I'm going to go back. Where is it? There it is. Here's 0, 0. I do not want to shade that. I want to shade on the other side of the line. So I'm going to click on this tool and then click right there, and that shades it. And you can see that the origin right here, 0, 0, it's not shaded green. Oh, and the other thing is this was a greater than but not an equal to. So this line should not be solid. I'm going to click on this tool and then click on the line, and boop, it changes to dashed. That means that any point on the line technically isn't a solution. However, you need to know where the line is so that you can shade correctly. So you have to draw the line, but we put dashes there. And now I'm just going to go up here and click on the how did it do, and it'll tell me that's green, that's green, that's green, that's all lit up green, I did everything right. And then of course here they give you the same explanation that I did, sort of. And that is that, and I hope that explains problem number 5.